Alright, this section we are going to talk about ratios and similar polygons. The first vocabulary word we are going to talk about is the word similar. Similar means that figures have the same shape, but not necessarily the same size. So if two figures are similar, they have the same shape, but not necessarily the same size. If you have two similar polygons, that means that the corresponding angles are congruent and the corresponding side lengths are proportional. So if we have two similar polygons, corresponding angles are congruent and corresponding sides are proportional. What that means is if you have corresponding sides in similar polygons, that means the ratio of the side lengths between the two polygons will be the same for all different corresponding sets of side lengths. The similarity ratio is the ratio of the length of the corresponding sides of two similar polygons. Alright, let me give you an example. If we have two similar polygons, triangle ABC and triangle DEF. The first thing we know, if these two polygons are similar, that means we can write a similarity statement. So we can say ABC is similar to triangle DEF. Now, when we write this similarity statement, the corresponding angles must match. So if this is our similarity statement, that means angle A must be congruent to angle D, angle B must be congruent to angle E, and angle C must be congruent to angle F. So that's one of the properties of similar polygons. You have three sets of equal angles. So angle A will be congruent to angle D, angle B will be congruent to angle E, and angle C will be congruent to angle F. And then you also have three sets of corresponding sides that produce the same ratio. For example, if you have side length AB, say side length AB is 2, and side length DE is 4. If you take the ratio of AB over DE, you get a ratio of 2 to 4, which is 1/2. Now, that is the same ratio you would get if you went side length CB over side length EF, and if you went side length AC over side length DF. So, when you have similar polygons, the ratios of the corresponding sides must be the same. Let's take and look at an example. Identify the pairs of corresponding angles and congruent angles and corresponding sides. First thing that we're going to do is we are going to set the congruent angles equal to each other. So if you take a look at your first triangle, this angle right here is 90, so you know that's going to match this angle over here. You see 59 here is going to match 59 here, and then with our third angles theorem, those two angles will also match. So we would say angle B is congruent to angle G, angle A is congruent to angle J, and angle C is congruent to angle H. Now, we know that those are congruent angles. We now will list the corresponding side lengths. So the first side length I'm going to take is BC. So I'm going to say, okay, BC is between the right angle and the one tick mark. So between the right angle and the one tick mark here would be HG. Now, we know that BC has a length of 6 and HG has a length of 3, so the similarity ratio for these triangles should be 2 to 1. Now that similarity ratio should be the same for all. So if we take another side length, 10 is from the right angle to the 2 tick mark, from the right angle to the 2 tick mark is 5. So we also know that AB over GJ also will have a similarity ratio of 2 to 1. And then we have our third sides. And if we did BC and AB, so now if we take AC, which is 11.6, and that would correspond to HJ, which is 5.8, that ratio will also be 2 to 1. So the similarity ratio for these two triangles is 2 to 1 for all the sides. Let's take a look at another example. If you look at example B, let's first of all list our congruent angles. So we have 1 tick mark here and 1 tick mark here, so we would say angle R is congruent to angle Z. The double tick mark would be angle O is congruent to the double tick mark angle Y. And then our last angle would be angle S is congruent to angle X. Once we have our equal angles, we are now going to list our corresponding side lengths. The first side length I'm going to take is going to be OS. So OS is between the double tick mark and the nothing. So between the double tick mark and the nothing here would be YX. And we know that is going to correspond and have an equal ratio of OR. OR is between the double tick mark and the single tick mark. So between the double tick mark and the single tick mark would be YZ. And then our last side on this original triangle would be SR. And SR is between the 1 tick mark and the nothing. Between the 1 tick mark and the nothing here would be XZ. And then we must also list our similarity ratio. Because the similarity ratio is the same for all 3 sets of corresponding sides, you can pick any one of the 3. So I'm going to start with 9, which was OS, and OS corresponded to YX, which was 6. So 9 over 6 reduced is 3 over 2, and that would be your similarity ratio. In the next example, we are going to determine whether the polygons are similar. If so, we must write the similarity ratio in the similarity statement. So the first thing we must do is look at the 2 rectangles. We know that AB must correspond to YX, so the first thing I would do is I would find the side lengths that would match accordingly. So if we have these 2 rectangles, if you kind of see proportionally how they're drawn, we would pick one of the side lengths in one of the rectangles. So I'm going to pick 10, and 10 would correspond to 15. And if these rectangles are going to be similar, then we must also make sure that that equals the other 2 sides. So 10 over 15 reduced is 2/3. And then we're going to check the next similarity statement. So we have 8 over 12. And 8 over 12 also equals 2/3. Because both the similarity ratios are the same with the corresponding side lengths, we then know that these 2 rectangles are going to be similar. So it says determine whether they are similar. Yes, they are. And then we write a similarity statement. And here's how you write a similarity statement. We start with rectangle. You take either one of the pictures. So let's start with the smaller picture, rectangle X, Y, Z, W. And that is going to be similar to rectangle. And then we must match the corresponding pieces. So X matches A, Y matches B, Z matches C, and W matches D. So we have rectangle X, Y, Z, W, and rectangle A, B, C, D. And those would be our corresponding rectangles. Let's try another example. As you can see, these rectangles look quite proportional as they are drawn, so we now must check the similarity ratios. So I'm first going to pick a side over here. So I'm going to pick 4. 4 corresponds to 6. Reduced, that would be 2 over 3. If we pick another side, 12, correspond to 16. Reduced 12 over 16 will be 3 over 4. Because your similarity ratios are not equal, you would say these two rectangles are not similar. If they are not similar, then you cannot write a similarity statement. Let's try example C. The first thing we know on example C is that they are similar angles there. The angles are all congruent. So we know that these two are right angles, which make them equal. These two are equal, and therefore, because your third angles theorem, these two will also be equal. So we know that all the angles are congruent. We must now check the side lengths. The reason we did not have to check the angles in A and B is because rectangles have 90-degree angles in every corner. So we knew that all the angles were going to be congruent for those. Next thing we do is we pick one of the sides. I'm going to pick 60. 60 is between the 1 tick mark and the right angle. So between the 1 tick mark and the right angle here is going to be 24. If you reduce 60 and 24, 12 goes into each of them, and you will get 5 over 2. And then we check the rest of the sides. I'm then going to check 75. 75 is between the 1 tick mark and the nothing marked angle. Here between the 1 tick mark and the nothing marked angle is 30. 15 goes into each of these. 15 goes into 75 5 times, and it goes into 30 twice. So far our similarity ratios are the same. And then I'm going to pick the last side. So I'm going to pick 45. And 45 is between the right angle and the nothing marked angle. So between the right angle and the nothing marked angle is 18. 45 over 18, if you reduce, they both go into 9 goes into both of them. You get 5 over 2. Because the similarity ratios are all the same, we now have found our similarity ratio, and now we must write a congruent similarity or a similarity statement. So we would say triangle JLM is similar to triangle S. J and S will match, L will match P, and M will match N. All right, on our last example, we will be doing the same thing. If you could look at the picture, you can clearly see that one of the angles are marked, and you can see if they were similar figures and the angles were equal, you can probably see that angle P and S will also be the same. So what I'm going to first do is I'm going to take a look and start with 8. 8 is between the double marked angle and the angle that's bigger than 90. So between the double marked angle and the angle bigger than 90, we have 6. Reduced would be 4 over 3. I'm then going to take another one. It's maybe side length 12. 12 is between both unmarked angles. The side length between both unmarked angles here would be 9. If you reduce those, 3 goes into both of those, you will get 4 over 3. And then we'll take our last side. So we have 18. And 18 would correlate or correspond to 12. And if you reduce those, 6 goes into this one 3 times, 6 goes into this one twice. Because all of our similarity ratios are not the same, you would say these two triangles are not similar. All right, let's flip the page, please. The next thing we're going to work on is we are going to work on writing ratios in simplest form. Our goal is to write the ratio of D to C in simplest form. Well, if I want the ratio of D to C, I'm looking for what D over C is going to equal in simplest form. So one way of looking at this is that we're going to kind of uncross multiply. So if you were taking a look at this, if I were to cross multiply and get 18C equals 24D, I would need to put the 18 up here and the 24 down here. If I did that, I would get 18C equals 24D. So that would be my ratio of D to C, and then we have to write that in simplest form. So if you reduce 18 over 24, 6 goes into here 3 times, into there 4 times, and that will be my ratio in simplest form. Next, Now we need the ratio of T to S. So you have to make sure that you write the ratio in the form they give you. T to S means T on top, S on the bottom. We then have to kind of uncross multiply this and get this to work with our cross multiplication here. So if this were true, 16 would have to be up here, 20 would have to be down there. So if you cross multiplied, you get 16S equals 20T. Once we have that, we must then reduce. 16 over 20, 4 goes into 16 4 times, into 25 times, so your ratio will be 5 over 4. Let's try another one. You have 25x equals 20y. You must find the ratio of x to y in simplest form. So, first thing I need to do is write x to y in the correct order, and then we must get our numbers here, so when we cross multiply we get this. So 20y means the 20 must go on top, and the 25 must go on the bottom. When you reduce this, 5 goes into 20 4 times, 5 goes into 25 5 times, and you have your ratio in simplest form. Okay, the next one, we have 16a equals 32b, the ratio of b to a in simplest form. So the first thing I would do is I would write b to a in that order they give you. We need 32b, so the 32 would go on the top, and the 32 would go on the bottom, and the 16 would go on the top. So if you cross multiplied, you'd get 16a equals 32b, and then you reduce. 16 goes into each of these 1 and 2, so your ratio in simplest form would be 1/2. On the next problem, we need to find the ratio of c to d. So again, we start with c to d. We need to get, so when we cross multiply, this is what we get. So 9c, so the 9 would go on the bottom, and the 21d would go on the top. So if we cross multiplied, we'd get that to work. Then we have to decide what goes into 21 and 9. 3 goes into 21 7 times, and 3 goes into 9 3 times. So our ratio in simplest form would be 7 to 3. Our next one, we are writing the ratio of x to y in simplest form. So we start with x over y. I then put my 14 on the bottom, my 35 on top. So if I cross multiplied, I'd get that equation, and then I reduce. 35 over 14, 7 goes into the top 5 times, it goes into the bottom 2 times. And you get 5 over 2. Our next example, Marta is making a scale drawing of her bedroom. Her rectangular room is 12.5 feet wide by 15 feet long. On the scale drawing, the width of the room is 5 inches. What is the length? We are going to set up proportions to solve these. The first thing I'm going to do is I'm going to start with her actual room. It is 12.5 feet wide and 15 feet long. And I'm going to start with that proportion. And I'm going to put a W out front for the width and an L out front for the length, so I remember the order in which it's written. On the scale drawing, the width of the room is 5 inches. Because this is the width, the 5 inches must go on top, and we need to find the length. So at this point in time, we are going to cross multiply. So if you cross multiply, 15 times 5 will get you 75. That's going to equal 12.5x. And then to solve, we're just going to divide by 12.5. And when you take 75 and divide by 12.5, the length is going to be 6, and it's going to be in the same units that the width was in, which is inches. Your next example, during the filming of The Lord of the Rings, the special effects team built a model of Sauron's tower with a height of 8 meters and a width of 6. So I'm going to start with that proportion. 8 over 6. 8 was the height, 6 was the width. We're going to set this equal to another proportion. If the width of the full-size tower is 996 meters, what is its height? Because we are solving for the height, we're going to call that variable x. Because they give us the width, we will put 996 this time on the bottom. When we cross multiply this, we get 6x equals, you go 8 times 996, you will get 7,968. You then divide by 6, and your answer will be 1,328 meters. and that will be the height of the tower. Our next example, a rectangle is 3.2 centimeters wide and 8 centimeters long. So that'll be my first proportion. 3.2 is your width, 8 is your length. We're going to set that to another proportion. A similar rectangle is 5 centimeters long. What is the width? Because we are trying to find the width, we're going to call that x. They give us the length to be 5, so we'll put our 5 on the bottom. From here, we're going to cross multiply. So we have 8x equals 3.2 times 5 is 16. When you divide by 8, x will be 2 centimeters. Our last example. A boxcar has the dimensions shown below. A model of the boxcar is 1.25 inches wide. Find the length to the nearest inch. So what we're going to do in our first picture is set up a proportion. 9 over 36.25. We're going to set that equal to another proportion. Corresponding to the 9 is 1.25. And corresponding to the 36.25 is x. From here, we are going to cross multiply and solve. If you take 36.25 and multiply it by 1.25, you get 45.3125. That is going to equal 9x. If you then divide by 9, x will then equal 5.03 inches. And that will be our new length.